Hello and welcome to part 3 of the Acids and Bases PowerPoint explanation video thingy. This is the last part, and I assume you are very excited.
I'm so excited.
Alright, anyway, if you want to follow along, bring up the PowerPoint, go to slide 67, that's where we left off. We last did sample problem 4, which is slide 66. So go to that one's called Reaction Between Acids and Bases. So, if you react an acid and a base, a neutralization reaction happens. In this type of reaction, you have an acid and a base reacting together to form a salt and water. So, these reactions are always double replacement reactions, and the salt that is made is the ionic compound made of the cation from the base and the anion from the acid. So, just as an example, you've got magnesium hydroxide plus hydrochloric acid here. One's the base, one's the acid. When they are in solution, the ions split apart into magnesium hydroxide, a proton, and chlorine. Once they have split apart, they rearrange, and you get magnesium with chlorine now, and the OH and the H plus go together, making salt and water. Here's an example of a problem that you might see. What is the salt formed from sulfuric acid, H2SO4, and potassium hydroxide, KOH? The base cation is potassium, the base being KOH. Since it has OH, it's a base. The acid anion is SO4 2-. Now, H2SO4, the H is what makes it an acid, and therefore the other stuff is the ion. So, if I ask you what the salt is, take those two cation and anion together, you get K2SO4, that is your salt. Another example is where you have aluminum hydroxide and hydrobromic acid. You take the ions, aluminum and bromine, stick them together, and there's your salt, AlBr3. Notice the leftover elements here are OH and H. If you take an H and an OH, combine them together, you get H2O. So water is the only other thing that is produced from this reaction. This leads you to try to figure out whether a solution is acidic, basic, or neutral after that salt is formed. If you have a strong acid and a strong base together, strong and strong, cancel each other out and you get neutral. If you get a strong acid and a weak base combined together, now the acid is the stronger one, so it will be an acidic salt. If you have a weak acid and a strong base mixed together, the base is now stronger, so you get a basic salt. As an example, determine if salt solution is acidic, basic, or neutral. LiBr goes to Li plus and Br minus. The acid that comes from this is HBr, and the base that comes from this is LiOH. HBr is a strong acid, LiOH is a strong base. Therefore, strong and strong, the salt is neutral. As another example, if you've got iron nitrate, FeNO3, the acid would be HNO3 because the anion, NO3, makes HNO3. There's your acid. That is a strong acid. FeOH3 coming from the iron here combining with OH hydroxide, that is a weak base. And since you have a strong and a weak and the acid is stronger, you get an acidic salt solution. So once we have these acidic and basic solutions, we need a way to tell the difference between them. This comes in the form of what's known as an indicator. An indicator will change color as the pH changes. The most common one is known as phenolphthalein. It's a long word, a lot of letters there. That is pronounced phenolphthalein. This changes between clear and pink as the pH changes. And just so you can see how this works, I don't know if you were aware of this, but when I was in college, I made a video called CSI Houston with the intent of using it along with a unit, basically to give students the chance to solve a crime according to given information over the course of various weeks. Now, it didn't fit into units very well, so I never ended up using it, but the YouTube video is still up, and here's a clip of me using some phenolphthalein in the intro. Kinda silly, isn't it? I like it in any case. It's fun. Another example of an indicator is that hydrangeas grow pink or blue depending on the pH in their soil. So the way indicators work is that they are weak acids or weak bases, so they don't change the pH very much when they're actually added into a solution. And in the acid form, they have one color. When they switch to the base form, they have a different color. Now, if you're interested in the actual hard chemistry of it, the idea behind these indicators is in different pHs, different protons attach to their structures. So more protons, and more acidic, makes the structure have more protons on it. This changes the actual geometry of the structures. It makes them twist and bend. As they twist and bend, light hitting them twists and bends as well. So in the case of phenolphthalein, at 1 pH, when there's a certain amount of protons attached to it, it's twisted and bended in a certain way to make it clear. As you change the pH, that makes it more pink because the entire thing starts bending the light around it. So the way these indicators are used is through a process called titration. Titration is the controlled addition and measurement of the amount of a solution of a known concentration required to react completely with a measured amount of a solution of an unknown concentration. Now, to simplify that definition, titration is basically taking a given solution of a certain pH and adding a more acidic or basic solution to neutralize it and tracking how much it takes to neutralize it in the process. So the reason we use titrations is to experimentally determine the concentration of a solution. Say if a bottle wasn't labeled, or if the label faded, or
if your chemistry teacher is very, very evil.
So, how do we conduct a titration? First thing you do is you measure a volume of a solution of an unknown concentration in a flask. Second is add 3 to 5 drops of an indicator just to allow you to see color changes. 3 is, while stirring, slowly add a measured volume of the solution of a known concentration into the flask. 4, use math to find the concentration you don't know. Now, I don't think you guys have very many books, but if you have a book, those pages will give you some more information if you're interested. But I know you're not, so let's move on. When titrating things, you have to know when to stop. Now, using various indicators don't always line up with what's called an equivalence point, but phenolphthalein does, and so you can make that distinction. You can think that when phenolphthalein changes colors, it's when moles of hydrogen ions equal the moles of hydroxide ions, basically when it's neutralized. The equation that goes along with this is very similar to the one from the last unit, where you have M1V1 equals M2V2, but rather than 1 and 2, you've got H plus and OH minus. Now, I mentioned before that the equivalence point wasn't exactly when the indicator changes. For phenolphthalein, it's very close, but it's not quite. The end point is not the same thing as the equivalence point. The end point is what's linked to the indicator. The end point is when you stop adding the known into the unknown. You use the volume at this endpoint for calculations. A sample problem is in a titration of 25 milliliters of 0.035 molarity barium hydroxide, neutralizes 16.5 milliliters of hydrochloric acid solution. What is the molarity of the HCl solution? So just like any other problem, assess the situation. Look at the givens that the problem has presented to you. Look at what it's asking for. It gives you volume there, molarity there, volume there, and it asks for the molarity. You're given a volume, molarity, volume, molarity. 2 volumes, 2 molarities, you plug them in, and because this PowerPoint doesn't have the answer written on it, I will tell you it verbally. The answer to this problem is 0.053 molarity. Now, at the moment, I can't exactly tell you how much you're going to have to use this type of calculation, or even if you will have to use this type of calculation, but it's good to know in any case, and I will give you more examples before you'll actually have to use it. That is it. We are done. I know there are 3 more slides, but we're not going to do those. That being said, thank you for watching if you did some watching, and I hope you weren't bored to tears. So, go and do homework and entertain yourselves and stay out of trouble, and I will see you tomorrow.